Imagine you're sitting back, scrolling through your feed, and you hear this headline. The oldest comet ever discovered is blasting water into space, and it might be older than the sun itself. Sounds like the plot of a Netflix sci-fi series, right? Well, it's not. It's real. And the name of this troublemaker? 3I/Atlas, our third confirmed interstellar visitor. And here's the disturbing truth. This object shouldn't even be acting the way it does. It's like finding a 110-year-old man running laps around the track with more energy than a teenager. Astronomers are scratching their heads, scientists are reevaluating what they thought they knew about comets, and the internet is doing what it does best, throwing out every wild theory possible from alien probes to galactic hitchhikers. So, let's rewind and get into why 3I/Atlas is shocking even the pros. First, the discovery. This isn't some backyard telescope find. It was spotted on July 1st, 2025 by the ATLAS Observatory in Chile. The system's job is normally to look out for asteroids that might smack into Earth. Instead, it flagged something way stranger, an object already more than 4 astronomical units away, beyond the orbit of Jupiter, moving on a hyperbolic orbit. Translation: this thing wasn't just swinging around the sun like a normal comet. It was passing through, never to return. Within hours, observatories around the world were rushing to confirm it. Now, here's where the disturbing part really comes in. When astronomers traced its path backward, they found that 3I/Atlas didn't come from any star system nearby. It came from the Milky Way's thick disk. If you're not familiar with that, think of our galaxy like a layered cake. Most stars, including our sun, live in the thin disk, a relatively younger part of the galaxy. But the thick disk? That's ancient. Its stars are old, between 7 and 14 billion years old. That means 3I/Atlas could have been formed before the sun even existed. We're literally looking at a cosmic relic older than Earth itself. That's already wild enough, but here's the kicker. It's still active. This thing isn't a dead rock just drifting through space. Observations showed it was already sprouting a faint coma, a fuzzy halo of gas and dust, even at 4 astronomical units from the sun. Most comets wait until they're closer in before they really wake up. Atlas basically started flexing before the race even began. And if you're thinking, okay, so what? It's just a comet. Here's why this has scientists unsettled. If this comet is billions of years old, it should be dried out by now. Its ices should be long gone, cooked away by eons of cosmic rays and star passes. Instead, we've got new data showing it spewing water at a rate of about 40 kilograms per second. That's like tossing 400 bottles of water into space every single second by an object that might predate the solar system. And we're just scratching the surface of what's weird about it. Its nucleus is massive, up to 11 kilometers across, according to new Vera Rubin Observatory data. For comparison, that's bigger than Mount Everest. But this giant isn't sluggish. It's moving at a blistering 60 kilometers per second, or over 134,000 miles per hour. Forget catching it. By the time you blink, it's already halfway across the solar system. Scientists expected interstellar visitors to be rare, fragile, maybe even unimpressive. Instead, 3I/Atlas shows up like a galactic linebacker, charging through with ancient ice reserves, still firing off into space. And here's a thought that'll keep you up tonight. If comets this old, this large, and this active are drifting through the galaxy, how many more are out there? How many have already passed by without us noticing? And what secrets about the origins of water, organics, or even life itself are locked inside them? Now, before we go further, here's your chance to be part of the crew unraveling these mysteries. If you're already hooked on the bizarre story of 3I/Atlas, smash that like button. It really helps get this video in front of more curious minds like yours. And if you're the kind of person who drops random space facts at parties just to look smart, go ahead and hit subscribe because trust me, you're going to want to keep this comet story in your back pocket because we're only just getting started. And in the next section, things get even stranger, like how something older than the sun can still act like it's fresh out of the cosmic freezer, all right? So we've set the stage. We've got a cosmic relic older than the sun itself, cruising into our solar system like it owns the place. But now, let's zoom in on what makes 3I/ATLAS not just fascinating, but downright bizarre when you look at the numbers. Because if you thought part 1 was strange, this is where the comet really breaks the rules. Buckle up. Let's start with size. Most interstellar objects we've found so far, like Oumuamua or Borisov, were modest in scale. Oumuamua, for example, was estimated at just a few hundred meters. Borisov, around a kilometer or two wide. Impressive, sure, but still small potatoes on the galactic scale. Now here comes 3I/ATLAS, casually rolling in with a nucleus. That new Vera Rubin Observatory data pegs at about 11 kilometers across. That's right, this thing is a literal Everest-sized chunk of ice and dust. Suddenly, Oumuamua looks like a pebble by comparison. And here's the disturbing twist. Something this big has no business being this active. You'd expect a comet this old and massive to be crusted over, insulated, and sluggish. Instead, 3I/ATLAS is venting gas and dust, like it's auditioning for the role of fountain of youth in a cosmic circus. It's as if you walked into a retirement home and found a 95-year-old running on a treadmill at 12 miles per hour. Scientists didn't see that coming, but size isn't the only jaw-dropper. Let's talk speed. 3I/ATLAS is tearing through space at nearly 60 kilometers per second. That's about 134,000 miles per hour. To put it in Earth terms, that's fast enough to get from New York to Los Angeles in under a minute. It's not just fast, it's unreachable by any spacecraft we currently have. If we wanted to chase this interstellar visitor, we'd need propulsion systems that still exist only on whiteboards and sci-fi shows. So yeah, good luck sending a probe. And yet, despite moving at this insane speed, 3I/ATLAS is stable enough to keep a rotation period of roughly 16.16 hours. That's the time it takes to spin once on its axis. Compare that to comets we know. Some spin like tops in just a few hours, others lumber around slowly over days. Atlas sits in a comfortable middle ground, twirling away as it spews out water and dust. Photometric studies even show its brightness variations are surprisingly modest, suggesting the comet isn't wildly elongated or oddly shaped. It's relatively uniform, like a giant ancient ice ball that somehow stayed in one piece during its billion-year galactic road trip. Now, what really messes with astronomers is the activity rate. Dust production is clocking in at up to 4 kilograms per second, while water production is blasting at around 40 kilograms per second. Remember, this isn't a comet fresh out of the Oort cloud. This is something forged in the galaxy's thick disk billions of years ago, wandering in interstellar exile for eons. And yet, when it enters our solar system, it suddenly behaves like a freshly baked comet, making its first dive past the sun. Where has it been storing all this pristine ice? And why is it still erupting? One possible explanation. Interstellar comets like ATLAS may spend most of their existence in deep freeze, literally cruising through interstellar space at temperatures only a few degrees above absolute zero. That kind of cold could preserve ice almost indefinitely, preventing it from evaporating like it would in a warmer star system. When it finally stumbles into a new solar system, it wakes up like a long hibernating bear. Only instead of stretching and yawning, it explodes in jets of gas and dust. But even that theory has cracks. Remember, 3I/ATLAS isn't just leaking. It's doing so aggressively, even at distances where other comets stay quiet. At 4 astronomical units, most comets are hitting the snooze button. Atlas is throwing a rave. Scientists are left with 2 unsettling possibilities. Either this comet is made of extremely volatile ices that are hypersensitive to sunlight, or there's something unusual about its composition that we haven't seen before. Both answers are intriguing and a little disturbing because they suggest we may have underestimated just how diverse interstellar objects really are. And here's where it gets fun for us, the audience. because while the scientists are scratching their heads and writing papers, we get to sit back and marvel. If this is only the third interstellar visitor we've ever confirmed, and it's already rewriting the rulebook, imagine what the 10th or 20th will do. What if some carry exotic chemistry we've never seen? What if some bring entirely new building blocks of life? What if, like some bold thinkers suggest, one of them isn't natural at all? Now, before we slide too far down the rabbit hole, let's keep this grounded. No one's saying 3I/ATLAS is an alien ship, though Harvard's A.V. Loeb has raised some eyebrows with wild theories, and we'll get into that later. But what scientists are saying is that Atlas challenges everything we assumed about interstellar objects. It's too big, too active, and too fresh-looking for its age. And that's exactly why the astronomy community is buzzing. All right, next up, the chemical mysteries of 3I/ATLAS. We'll talk about the bizarre gases, or lack thereof, coming off this comet and why it has scientists torn between awe and confusion. Stay tuned. Now here's where things get seriously unsettling. You'd think after billions of years drifting between stars, a comet would be more or less dead, just an inert chunk of rock and dust. But 3I/ATLAS is proving to be anything but. When astronomers pointed their instruments at it, they found chemistry that flat out shouldn't be there, at least not in the way it's showing up. Let's start with what they didn't find. Early spectroscopy picked up a faint reddish hue on the comet, which usually suggests organic compounds, complex carbon-rich materials. That's not too surprising. We see that on other comets. But what baffled observers was the absence of the usual gaseous suspects. Where was the cyanogen, the carbon monoxide, the classic comet perfume that we've come to expect? For weeks, telescopes reported silence in those key emissions. Then suddenly, things changed. At the end of July, NASA's Swift Space Telescope caught something nobody was expecting: clear ultraviolet signatures of OH radicals, which form when water molecules are split apart by sunlight. Translation: 3I/ATLAS was sublimating water, and not just a little. It was pumping out water vapor, even though it was still 3.5 astronomical units from the sun. That's farther out than the asteroid belt, a region where most comets are still pretty much snoozing. The numbers are jaw-dropping. Models estimate that Atlas is venting water at around 40 kilograms every second. That's the equivalent of launching an entire cooler of bottled water into space every heartbeat. And this isn't just trace activity either. The coma contains icy grains, meaning chunks of frozen water are literally breaking free and being carried away by gas jets. For an object thought to be older than the sun, that's like finding a fossilized tree that suddenly starts sprouting fresh leaves. It doesn't make sense. So why does this matter? Because water is one of the most fragile substances for a comet to hold on to over cosmic time. If 3I/ATLAS really formed 7 to 14 billion years ago in the thick disk of the Milky Way, that water should have been long gone, vaporized by radiation or cosmic rays. Yet, here it is, erupting in our backyard like it was put on ice yesterday. One theory suggests that interstellar space, while harsh, can also act as a kind of deep freeze. Temperatures out there hover only a few degrees above absolute zero. If a comet spends most of its life drifting in that freezer, its ices might stay preserved for billions of years. Only when it falls into the gravity well of a star does it wake up. That's plausible, but it still doesn't explain the level of activity we're seeing at such a great distance. Another unsettling clue came from color changes. Over late July, the coma of 3I/ATLAS became noticeably redder, which suggests the presence of complex organic dust grains being lifted from its surface. Imagine ancient carbon chemistry, older than our sun, now being exposed to light for the first time in billions of years. What kind of molecular secrets are locked inside that dust? Could it resemble the building blocks that seeded early planetary systems? The possibilities are huge, and honestly, a little eerie. And then there's the rotation, with a spin period of just over 16 hours. You'd expect Atlas to show strong brightness variations as sunlight reflects off irregular surfaces. but the changes are small, only about 0.3 magnitudes. That means either the comet is surprisingly spherical, or its surface is unusually uniform in reflectivity. Either way, that's weird. Interstellar space is brutal. After billions of years of impacts and radiation, you wouldn't expect an object to look neat and tidy. But 3I/ATLAS seems to have aged almost gracefully. All of this leads to some disturbing questions. If water and organics can survive intact for billions of years in deep space, then interstellar objects might be the ultimate delivery system for life's ingredients. They could wander from system to system, spreading organics, maybe even shaping the chemistry of young planets like Earth. In other words, comets like ATLAS might be the galaxy's gardeners, silent couriers of the raw stuff of biology. And if that's true, then this isn't just an astronomical curiosity. It's a clue to how life might spread across the stars. Of course, the scientific community isn't done poking at the puzzle. Every major observatory is booking time to watch ATLAS before it slips away forever. Hubble's on it. The Vera Rubin Observatory's watching. Even the European Southern Observatory is lining up. Why? Because nobody wants to miss the chance to study what may be the most pristine interstellar time capsule we've ever seen. But here's where you come in. If you're fascinated by the idea that the same kind of comet that might have watered Earth billions of years ago could now be flying past us from another galaxy neighborhood, hit that like button and share this with a friend who thinks comets are boring. Trust me, they'll thank you when they realize one of them might literally carry the story of life itself. And if you thought water spraying out of a billion-year-old rock was shocking, wait until you hear about the controversies this comet has stirred. Because some scientists don't think it's just reflecting sunlight. They think it might be generating light of its own. Yeah, buckle up for that one. Now, if everything I've told you so far sounds bizarre, brace yourself, because this is where 3I/ATLAS goes from mysterious to downright controversial. See, when astronomers study comets, there's usually a comfortable set of expectations. They brighten as they approach the sun. They release familiar gases. Their orbits behave in predictable ways. But Atlas, it's rewriting the playbook. Some researchers have noticed subtle anomalies in its activity. For one, the comet's brightness doesn't always match the amount of dust and gas it's releasing. Normally, those two things scale together. But Atlas has stretches where it seems brighter than it should be, as if there's another light source at play. That's led to whispers of something called electroluminescence, the idea that charged particles streaming from the sun could be interacting with the comet's surface or coma, causing it to glow faintly. Sounds fringe, right? But when you're dealing with a billion-year-old traveler from beyond the stars, fringe ideas start getting serious attention. Then there's the orbit itself. Sure, it's hyperbolic. It came from interstellar space, and it's leaving again. But high-precision tracking shows tiny deviations in its path, nudges that aren't fully explained by gravity alone. With Oumuamua back in 2017, those same kinds of deviations sparked headlines about alien light sails. Harvard astronomer Avi Loeb became famous, and infamous, for suggesting it might have been artificial. Now, with 3I/ATLAS, he's urging the community not to dismiss unusual data so quickly. His argument? If one interstellar visitor already challenged our assumptions, maybe we shouldn't rule out exotic possibilities for the next. Most scientists are cautious, though. They point out that outgassing, jets of material escaping the comet's surface, can easily push the orbit around a bit. But here's the catch. Those jets don't seem powerful enough to account for all the changes observed. So we're left with a maddening gap in the explanation. Nothing alien, nothing conclusive, just a cosmic shrug that makes people uneasy. And here's where the timing ramps up the tension. By mid-2025, Atlas is sliding toward its closest pass to the sun, perihelion. For a brief window, it'll be lit up and easier to study. But then, it's gone, forever. Out of our solar system, back into the void, never to return. That's what makes this object so haunting. We have one shot to collect every scrap of data we can before it disappears into darkness. Imagine it, a 4-kilometer-wide iceberg of primordial dust and ice, older than the sun, carrying chemistry from the galaxy's thick disk, maybe even older than Earth itself. And we only get a few months to peek at it before it slips away into interstellar night. If that doesn't give you goosebumps, I don't know what will. So what's the disturbing truth about 3I/ATLAS? It's that we don't really know what it is. A comet, sure, but one that breaks rules, preserves impossible chemistry, and challenges the limits of what we thought interstellar objects could be. It's a reminder that the universe is still full of mysteries that don't fit neatly into our textbooks. And that maybe, just maybe, we're looking at a messenger, not of aliens necessarily, but of cosmic history written in frozen stone and ice. Now, before it fades from our skies, the question becomes, how much will we learn, and how much will slip away with it? Will ATLAS end up as just another weird data point, or will it become the object that forces us to rewrite how we think about interstellar wanderers? And this is where I'll leave you, with one final thought. Every time we spot an interstellar visitor, we're reminded that the galaxy is not a set of isolated solar systems. It's a connected neighborhood. Objects travel, chemistry travels, maybe even the seeds of life travel. Atlas is just passing through, but it's whispering a story that ties us to the broader cosmos, and that, more than anything, is why it matters. So, if this journey through the strange and unsettling world of 3I/ATLAS has fascinated you, hit that like button. It helps more curious minds find their way here. Make sure to subscribe, because we're going to keep chasing the biggest, strangest questions the universe throws our way. And share this video with a friend who loves space as much as you do, because trust me, this is one story that deserves to be told around the world. The disturbing truth is simple. The universe is weirder than we imagined, and 3I/ATLAS is proof. And the next time a visitor from the stars comes knocking, we better be ready, because it might just carry answers we didn't even know we were asking.